Okay, so we get to an interesting point in our synthesis because you've been introduced to new reactions, right? So you got a reaction recently where you said, you know what, you can make a Grignard reagent, right? And the Grignard reagent can act like, watch this, a nucleophile. I'm going to try to, okay? That can act like a nucleophile, right? Remember this? Boom. Man, everything is going wrong today. I am complaining. Okay, and that can go there, right? Now, that's awesome. Okay, that's a very powerful reaction. I've got to plug my computer in. Hold 1 second. I tried ignoring this warning message recently and lost the video, so I'm not going to ignore that anymore. All right, so this we know can happen, right? And this is awesome, very cool. However, we have a problem because if you've got a bunch of this stuff, right, it's a bath. You have a bunch of molecules of this stuff, right? And let's draw another one that's backwards. You have a bath of it, agreed? Okay, what's going to happen? Aha, this is also going to react with the hydrogen. So this will not happen. This is too fast, right? The alcohol can act as an acid, especially in the presence of reactive reagents like the Grignard, which I've got here, okay? So how do we do this kind of reaction? If we ever want to get this connection here, how do we get this? Aha, we can protect the alcohol to prevent it from reacting. All right, and that's what this section's about. So look at here. Let's take this. Let's take what's about to be a Grignard reagent, okay? And let's cap this alcohol. Okay, and there's our cap right there, right? So we've got some kind of cap on there so that the Grignard reagent, once we make it, it's not going to see it. It's dead to the world, okay? Now, once we get that, then we can treat this with magnesium. Magnesium metal, right? And when you treat that with magnesium metal, you can get your Grignard reagent, right? Once you get your Grignard reagent, then you treat your carbonyl compound. Okay? And then we get this, right? Well, I guess once we do that, we've got to chase it with water. We've got to protonate. Right? We've got to add that proton on the end. Okay? After we do that, aha, then we deprotect. We take the cap off. Okay? Okay, we take the cap off. And then we got it. We got what we need. Bam. All right? This is not an unusual method, and so I do hope that you'll, hope you'll, put your head in this. We're going to use it again, this method again later in the semester. So it's very cool, very clever, not nearly as complicated as it looks. So anyway, now let's talk about how we're going to cap it. So one way we can cap this is with TMS, or TMSCl really, okay? The cap that we made in the previous slide might have been this, right? There's a couple kind of caps that we can use, but this is the one that we're going to talk about right now. So once we introduce that cap, there's the cap right there. It's capped, right, or protected. The Tms Protection Group requires the presence of a base. So if you make this, here's your use. You use your trimethyl silyl chloride, right? Trimethyl silyl chloride, and it requires the use of a base. So I have an amine here, right? It's a tertiary amine. And once we do that, so this is what you're memorizing here. You're memorizing these reagents here, okay? Which you can just call this TMSCl. It's got it here, but don't forget what's going on, okay? And then after you treat this with TMSCl and amine, you get your cap. Really, a cap is all here. okay? And you get this other stuff, which we don't care about. So when I'm drawing this in class, or on an exam, I probably will skip it when I'm drawing it, because it's counter ions. These ions we don't need. Okay. All right. That's one way that we can cap this or protect it. Now, why is TMS a good cap? Why is it a good cap? Well, it's because the substitution of the silicon atom can occur by an SN2 mechanism, and the silicon's much larger than carbon, so you can get the backside attack, right? This is there's your chloride right there. See that chloride on the back, or chlorine on the back? Okay. Well, you're not. If you do a carbon in the middle here, you've got your 3 methyl groups around there. You got too much steric hindrance for the nucleophile to get in there. What's the nucleophile in the reaction we're talking about? What is the nucleophile? It's the OH. There's not a negative on there, sorry. It's an OH, okay? So this goes in here. Of course, there are some, since we have a base in solution, you know what? Let me say that again. I wish I could just erase that. Does this do a... No, it doesn't. Okay, this is really ugly. Can you pretend you can't see that? Thank you. So we have a base in solution, right? And it's triethylamine, right? So the base, there is going to be some deprotonated presence of your alcohol in there, right? Not much, but once this gets your backside attack, boom, then your equilibrium is going to draw more of that into solution. All right. So this is what the attacker is. It's here, and you know that because you've got a base in solution. I'm writing out base, okay? What's that for? And I just answered what it's for right here, but in case you fell asleep while I was talking, that's what the question was about. All right, so this is how TMS works, or TMSCl works. And the question then is, how can we get it off? Well, we can either get it off with acid or with fluoride, and TBAF is one method. This is really ugly. You know, you really don't even need to know that. You need to know that this is really a way to deliver fluoride ions. That's it. Okay? Acid or TBAF is a way that you can remove the protecting group. Okay, so let's go now back to the specific instance. Suppose we've got this, I don't know, it's a propanol, right? So it's 1, 2, 3. It's 3 bromo, 1 propanol, right? You protect it, you cap it, then you add your magnesium, right? You make your Grignard reagent. Is that too small to see? I don't have enough room there, do I? Make reagent is what that says. It looks like a bunch of scribbles, I know, on your screen, but making your reagent, you're making your Grignard, and then after you make your Grignard, you bring your Grignard in to attack that. Just a second here. Right? This comes in and attacks that. Boom. And then we protonate. Okay? And then you still have your cap on there. Then you uncap it. Boom. And you've got it. Got your stuff back. Wow, very cool. All right. Now you need to go and practice with conceptual checkpoint 13.8. Okay. And after you've done that, you're done.